Hello students, welcome to Learners Academy and today we'll study the remaining part of the lecture Physical World. Today we'll study the remaining topics of the chapter Physical World, and it is very important for the students who are preparing for any competitive exams as well as for the students who are preparing for Mastercadre exam for science teacher in Punjab region. So let us start with the first topic, that is fundamental forces in nature. In this we'll study gravitational force, electromagnetic force, strong nuclear force and weak nuclear force. Let us start with the first force, that is gravitational force. It is the force of mutual attraction between any two objects by virtue of their masses. It is also known as universal force because as every object experiences this force due to every other object in the universe. For example, if we take the falling of an apple on the ground, at that time the apple as well as the ground experience the same force by virtue of their masses. Similarly, in case of our solar system, the planet and sun experience the same force because of their masses. So this is known as gravitational force. The next force we are having is electromagnetic force. In this, the force between the charged particle is known as electromagnetic force, and the charges at rest experience electric attraction because it happens between unlike charges, and the charges who are like, they experience repulsion, and when charges in motion produce magnetic field, that is known as electromagnetic field or electromagnetic force. For example, in this picture we are having like charges and unlike charges. The unlike charges are experiencing attraction, however the like charges are experiencing electrostatic repulsion. Also, it is the example of an electromagnetic field where the charges in motion are producing electromagnetic field. So this is all about electromagnetic force. The next topic we are having is strong nuclear force. The strong nuclear force happens between the proton and neutrons because it is an attractive force, and it is charge independent and acts equally between a proton proton, a neutron neutron, and a proton and neutron. And the recent discovery shows that the protons and neutrons are built of elementary particles that are known as quarks. For example, if we study the structure of atom, let us take the example of lithium atom where three electrons are there along with the proton and neutron. In the nucleus of lithium, the protons and neutrons are tightly held with each other because they are charge independent and they are experiencing attracting force, which is known as strong nuclear force. This is the example of Bohr model of atom of lithium atom. So this is strong nuclear force. The next force we are having is weak nuclear force. The force appears only in certain nuclear processes such as beta decay. Actually, in beta decay, when nucleus emits an electron and an uncharged particle, which is neutrino, that is known as beta decay, and because of weak nuclear force, the nucleus emits electron and neutrino, and the particles which was first predicted by this is known as neutrino, and it was developed by Wolfgang Pauli in 1931. In beta decay, when nucleus lose an electron, then it also lose another particle that is called neutrino. After leaving it, it becomes unstable and it produces other atoms. So this is all about weak nuclear force. Now we are having the properties of forces. In properties, we are having the range and the areas where they operate. First is gravitational force. The range of gravitational force is 10 raised to power minus 39, or you can say infinite, and it works on all the objects in the universe. And the second is weak nuclear force. Its range is 10 raised to minus 13, and it works on some elementary particles, particularly on electrons and neutrino. And the third force we are having is electromagnetic force. Its range is 10 raised to power minus 2, and it between with charged particles. And the next force we are having strong nuclear force of range having 1, and it works among nucleons heavier elementary particles. So this is the property as well as the ranges and the areas where these forces work. So it's all about the properties of the forces. The next topic we are having is conserved quantities. Before studying the conserved laws, we should know what are conserved quantities. The physical quantities that remains constant with time are known as conserved quantities. For example, if a body under external force, the kinetic and potential energy change over time but the total mechanical energy remains constant. Also, the conserved quantities can be scalar and vector. For example, if we take the ball which is at rest and taking the similar ball which is in motion, if we count the total mechanical energy, then it would come out to be same, it would come out to be constant, because the movement the ball is experiences because of kinetic and potential energy which makes it constant. So these are known as conserved quantities. Now let us study conservation laws. The first of all, we should know what are conservation laws. Conservation laws are nothing but these are hypothesis based observation and experiments which cannot be proved. However, they can be verified by experiments. So the first law we are having is law of conservation of energy. The law of conservation of energy states that energy can neither be created or nor be destroyed. However, it may be transformed from one form to another. To explain this, we should take one example of energy transformation. In this picture given below, the plants are taking the energy from sunlight. Sunlight is itself a unified energy which is available everywhere, and every plant uses it to prepare food. And in this process, the first energy we are having is solar energy, which is used by plant to produce food, and the energy changed here in the form of chemical energy. And third, the log of the tree can be taken as the third type of energy. And finally, the log produce the fire which is known as the other form of energy. So here you can see that energy can neither be created or nor be destroyed. However, they are transforming from one form to another. If you remember, then in the 10th standard we have studied the 10% law, where we study that the 10% of energy transform from one form to another form. So this is same as that law of conservation of energy. Now let's move to the next, that is law of conservation of mass. The mass in an isolated system can neither be created or nor be destroyed, but can be transformed from one form to another. This is law of conservation of mass. Now the law of conservation of linear momentum. If the net external force acting on a system of bodies is zero, then the momentum of the system remains constant. This is law of conservation of linear momentum. And the last law we are having is law of conservation of angular momentum. The law states that the law of conservation of angular momentum states that when no external torque acts on an object, no change of angular momentum will occur. So these are the law conservation laws which are important and which we'll discuss in detail in further lectures. So this was all about the lecture. If you like the lecture, kindly subscribe to our YouTube channel and kindly press the like button and press the bell icon for the further notification, and you can comment in the comment section for any suggestion or any query, and you can follow us on Facebook, Instagram and LinkedIn. Thank you for watching the video. Good luck.